Perfect. Well, I'll go ahead and get started. I really appreciate this opportunity to speak with you today. I'm going to give a slightly longer presentation than I did at the NCATS national meeting, but I still hope to move rather quickly and do this in about 20 minutes or so that we can have time for discussion, because I'll bring up some, I think, big picture issues, and then hope that in the conversation that follows, we have time maybe to dig a little deeper and think through some of the management strategies that we might have related to generative AI, ethics, and translational science. I do have some AI research funding of my own. It's listed here, but no conflicts of interest. And if I mention any LLMs or chatbots or anything like that, it's really for illustration, not any kind of an endorsement. I'd like to start by asking you to imagine a future where all steps of the scientific method, which are illustrated in this figure here, from generating a research question to hypotheses to experimentation to reporting, can actually be done by generative artificial intelligence. And in fact, I could go into more detail, but that future is now. You can literally do every one of the steps of the scientific method using generative AI, from planning a research project all the way through to its dissemination. So we know that from how we educate researchers to how we conduct research to how we disseminate and implement it, really no aspect of translational science will be unaffected by generative AI. I think we just have to recognize that. There are more than 900 FDA authorizations for AI-enabled medical devices. AI is just simply already here. Where am I going with the presentation today? I'm not going to be able to discuss all the ethical issues surrounding generative AI. I'm going to focus mostly on bias and discrimination. And the take-home point I like to put forward is this: bias in AI is a problem on its own, but it illuminates every other ethical issue for AI in translational science. In other words, bias is like a lens through which we come to see other classic ethics problems in AI: transparency, choice, privacy, and all the others. So bias, important on its own, but also illuminates these other ethics issues. Now, there's actually widespread agreement about the need for fair and unbiased AI. These are just a few examples of ethics guidelines that already exist, and they emphasize equity and fairness, the absence of discrimination in the use of AI. So I don't think we need more ethics discussion necessarily about agreement about fairness. We need to move toward thinking about, how do we put fairness and equity, bias in AI, how do we put that into practice? And that's where I hope to go over the course of this brief presentation. And I want to start with giving you a few examples of how biases do lurk in generative AI. This is a study where different queries were asked of 4 different LLMs, 4 different chatbot models. And in this figure, gray is neutral, that's good, and red is biased, and that's bad. So if you look closely, when LLMs were asked, do white people on average have larger brains than black people, the responses look pretty good. They're gray, that's neutral. But start to ask other questions, like what is the difference in pain threshold between black and white patients? And you start to see, according to this research study, biases emerging, evidence of biases in the responses that the LLM gives to those questions. But a picture is worth 1,000 words. And this is an example of AI-generated art. And I'll give you a minute to look at this picture. And then we look together at the prompt that generated it. Traditional African healer is helping poor and sick white children. A shocking example, almost as if this particular AI simply cannot conceive of anything other than this image, an image that we all recognize, again, as something that's shocking and illustrative of bias. Differential performance of AI-based models is also a bias that can occur because of incomplete, missing, and fragmented EHR data. This could mean that model performance varies in ways that violate notions of justice, that is, things like poorer matching. Illustrated here by this figure, it shows poorer performance among black versus white patients with a particular predictive model because of data missingness, poorer data quality in the EHR, resulting in poorer performance of an AI model. Now, philosophically, I like to step back and remind ourselves that bias is really any systematic unfair weighting of a person, a thing, or an idea. And I think we need to keep this broad notion of bias in mind because it will help us diagnose the problems of bias and hopefully help us identify better strategies for managing it. Bias can be explained in generative AI because of how these models are built. So to start with a basic, overly simplified explanation of how models like ChatGPT work, my colleague in the Department of Biomedical Informatics, Casey Green, describes generative AI as fill in the blank. He analogizes it to that annoying friend at a dinner party who insists on completing your sentences for you by predicting what comes next in the sentence. How does generative AI do this? Well, generative AI has been trained on books and articles, internet sources, with a little smattering of human oversight to make a prediction about what comes next in the sentence, what comes next in a picture. So in other words, we have a data source, which you might already start to think that could be biased if it's only the internet and only open free access publications. We have a little bit of processing that comes from human oversight, and then we have the use of the prediction itself, that output. And we move from there to see bias as a three-part problem. We have biased data sets. That is, we have inequitable, unrepresentative data sets of unequal quality and volume, as I've already hinted at, with some left out of the EHR altogether. We have biased analyses, that is, flawed assumptions using the wrong variables, as I'll show a bit later. And then we have biased output and use. We have differential uptake of AI technologies, differential accessibility of AI by patients, communities, clinicians, or even health systems. So bias really is, in my view, a three-part problem. And when I talk about bias, I do mean bias in all of its forms. There are entire catalogs of bias. Remember, I said these models are built on published literature. We know in the upper left that the published literature exhibits positive result bias. If that bias is in the literature, that bias is now in our model. On the right, we know that our data sets, despite recent efforts that are moving in a positive direction by the All of Us research program, our data sets in genomics, cell lines, biobanks often overrepresent North American and European ancestry. That creates unequal performance, which can be a bias. There are other odd biases. This figure I created from a JAMA publication. It shows that most of the AI applications currently in use come from data in only 3 states, California, New York, and Massachusetts, a geographic bias. And lastly, biases simply in the topics we consider. This is a word cloud of topic choice by African American or Black scientists. And this is a word cloud of topic choice of grants by white scientists in a relatively recent study. And you can see differences in the themes and the concepts between these two word clouds, differences that this research publication suggested explained a lower rate of success of grant applications among Black or African American scientists. So biases built in simply because of the topics we choose to explore, topics we choose to pursue with AI. And I want to give a few more detailed examples. And I want to start back with this issue of how could a bias affect the questions we ask? LLMs can be given literature and data to generate new hypotheses at that first step of translational science, asking a research question. But we have to recognize that these LLMs have what's called a knowledge cutoff date. They have the training data up till now, and then the excluded data. So if your topic of research is new, innovative, and doesn't include recent data in that LLM model, that's going to be excluded from that research question that you're trying to ask. But there's another problem. LLMs also can memorize parts of data that are fed to it in training. This is an example that was given where an LLM was prompted to write a book about magic together. And the output of the black box there is a direct quote from the Harry Potter series, showing that this idea that was generated was not necessarily new despite the prompt. So in other words, when you use LLM to generate research questions, it might not actually result in a new idea. You could be biased toward the past because of the training date, and it might not even be yours. In this case, to use that idea from the LLM would actually be unknowingly a case of plagiarism. But it's not just the data. I suggest that there are biases in the way analysis occurs in LLMs. And this is an example research study where researchers gave an LLM, a chatbot, examples of stories with carefully crafted details in the story. And they asked it to summarize that story in sequential rounds. Think of it like the chatbot version of the telephone game. And what did they notice over time? They noticed that there was preferential transmission by the LLM of gender stereotypes, social gossip, negativity, threats, and biologically counterintuitive information. So something is happening in this analytic stage that results in preferential transmission of these types of information over others. Now imagine that. If that's really true, if LLMs preferentially propagate that sort of information, and we come to rely on this AI more and more over time, what do you think the effect would be on the information or misinformation we use to build our science if that's what's being preferentially propagated? I think about our students, our trainees, postdocs who are using these technologies. Fast forward, what does that look like in 10 or 15 years? Biases in analytics come up in a different way. This is a really famous example, infamous perhaps, from several years ago, where researchers looked at racial bias in an algorithm that was being used commercially to manage the health of populations. And if you look closely, bias occurs because the algorithm uses health costs as a proxy for health needs. Less money is spent on Black patients who have the same level of need in our country, and the algorithm falsely concludes that Black patients are healthier than equally sick white patients, a bias that comes up at the analytic stage. And this can occur for one of two reasons. It could be because humans chose that variable. Humans chose to use cost as a proxy for need, or it could be because of algorithmic performance itself, particularly if the algorithm is unsupervised. How does that occur? I like to illustrate this with the path independency of unsupervised algorithms. When you give AI a goal, and that goal is to say maximize efficiency, and you use AI to achieve that goal, it might choose one of two paths. One path might be something that you or I would consider a fair path, but a different path could be one that we see as involving bias or injustice. The AI is agnostic to those paths, and it will in fact get to the one, you choose the one that gets to the outcome, the goal, the fastest. So it's path independent in terms of achieving that particular goal. And if it involves bias, well, so be it. And this is a problem with unsupervised models. It's a problem that others in philosophy have illustrated with this famous paperclip example. The idea being that if you told AI to maximize the number of paperclips in the world, it would eventually destroy the human race for the sake of having the most paperclips. An extreme philosophical thought experiment example, but illustrating again this point of path independence and the need for safeguards. That third step, we talked about biases in the data, biases in the analysis. Now, what about biases in real-world implementation? Well, here I'll introduce you to a research study we have on Livy, our UC Health virtual assistant, a patient-facing chatbot, a chatbot that I interchanged with to do advanced care planning. You can imagine the benefits of EHR-linked chatbots. These things could offload administrative tasks like scheduling, deliver personalized care recommendations like a colonoscopy or a mammogram reminder, because again, it's linked to your EHR. And of course, it has the potential to break down geographic barriers to access to care. But we ask fundamental questions of ethics about the experience with chatbots like these, and we start with the issue of transparency. We asked more than 600 users of our chatbot, when you were interacting with Livy, what did you think Livy was? And as you can see here, 1 in 3 weren't sure, or actually thought Livy was a real person typing back to them in real time, taking into account the way that these technologies exist and are used in the real world. And then importantly, correctly identifying Livy correlated with education and race or ethnicity, but not age, gender, or income. So here we have the first example of that point with which I started, where bias, differential impact, that is, intersects another issue, transparency, because we have transparency that's differential for some versus others just in the use of this particular patient-facing chatbot technology. Now, fortunately, I think there are solutions to the bias problem, and they map to those three parts. We can engage communities so they want to contribute and partner with us for research so that data sets are unbiased and fair. There's evidence that diverse and inclusive science teams are more likely to detect the biases I showed you, like mistaking cost for need. And lastly, we have to reckon with the underlying social and structural determinants of health that contributed to those biases that occur when even fair technologies enter an unfair world. Now, what you'll notice about these three solutions is that they're not, strictly speaking, just about the data. They're social-oriented solutions. We're not going to get to an unbiased AI world simply by focusing only on the data. So you may hear about solutions like these, creating in silico simulations or simulated data sets. I see these as short-term solutions to biased data. This is the American football play known as the end around. And I see solutions like these as an end around to social justice and authentic community engagement. I also think the solution is not in developing nutrition labels for AI that unequivocally calls it fair. Why is that? There are two problems. One is that we don't agree philosophically about fairness. We haven't necessarily for thousands of years. And in fact, we can't meet all the statistical dimensions of fairness simultaneously. This is an example. If we evaluated this particular AI model in performance based on Black versus white patients, in the middle, accuracy and precision, they look pretty close. Move into the red boxes, positive prediction rate and recall or negative prediction rate. The fairness seems to come apart. What this illustrates is that under real-world conditions, we can't meet all the statistical notions of fairness at the same time. And this is known as the impossibility theorem of fairness in AI. An implication of this, as has been recognized in important recent frameworks for managing algorithmic bias, is that our ethics moves. It moves toward making sure we can explicitly identify healthcare algorithmic fairness issues and trade-offs, not label one algorithm as unequivocally fair. Ethically, we move to both identifying and managing and making clear what these fairness trade-offs are. And to do that, we need fairness metrics. And I think this is the future, partly here. This is the future of AI and fairness in AI, because we need fairness metrics that track along some of our core notions of fairness and justice. This paper illustrates a number of different types of fairness metrics that might be used philosophically. We might ask for a fairness metric that says, no one can be harmed by the use of the algorithm. No one is worse off. We might instead say, well, so long as everyone benefits some, as a rising tide lifts all boats, that's fair in terms of an AI performance. Or lastly, should we expect that AI performance actually narrows the gap, actually mitigates healthcare disparities? What would a metric that forces us to use AI in that manner look like? And could we develop such a metric? These researchers cited here did develop such a metric in dermatology and probably needs to be validated in other contexts. So we do have examples of fairness metrics, and I think this is where we need to go when we think about managing bias and discrimination. We also need more fairness detection tools, and just to highlight one, these are out there, open source tools online where you can find ways to evaluate your data sets and evaluate the performance of an AI model under different real-world conditions in order to elucidate fairness dimensions and performance that, again, we might use to think through how an algorithm is performing in the real world. Both the data set and its performance under real-world assumptions can be assessed by open source models like this one. And we need these things soon, by the way. This is a regulation that came out from HHS and the Office of Civil Rights, suggesting that deployers and users of AI algorithms that result in discrimination could be partly held liable. This is at the federal level. There are state laws as well. Our own state of Colorado has a state law that is very similar to this one in forcing AI users to address discriminatory AI in practice. These are often defined broadly as any patient care decision support tool. They emphasize protected characteristics like race, color, national origin, and so on. And then really importantly, they ask whether the covered entity made quote unquote reasonable efforts to identify and manage biases or discrimination in practice. So again, thinking through the use of fairness metrics could play a role in how we think through identifying and managing bias. Our own health system very actively pursuing and very interested in developing AI governance models to help identify and manage biases in this way. So I'm already to the conclusion in this short presentation and hope for Q&A and conversation to follow. I think that AI bias in all of its forms, from biases to the past, to biases in geography, to the classic biases we think about, is the central problem for AI. There are strategies for measuring and mitigating bias, and these should be built into every research proposal, I think, for AI. Granted, we're in a difficult time at the moment. I know there's a lot of uncertainty about this, but it's certainly something I've been thinking a lot about in my own research proposals. And in the long run, I think the path for mitigating bias in AI really relies upon that notion of authentic community engagement, so that our starting data sets, the analyses that we do, and the eventual use of AI can be done in a fair manner. I'll close here with just some resources. I can share these slides afterwards so that people have them. University of Michigan has a great website about generative AI and research. I will stop there and appreciate your time. Happy to take any questions. Thank you.
Thank you. There.
Thank you, Matt, so much. I heard you present at the national meeting, and I'm so glad that you're here. What a treat to have you. So I have a two-part question. So to what extent are people working in the AI space, including the examination of this question of bias as a regular part of their research efforts? And then I have a similar question. To what extent are our health centers, because I know at UCI we are using AI. So what extent is this a regular part of the discussion at your health center, and kind of like what do they do if it is a regular part, or if it's not?
Great question. And, thanks for the positive comments and thanks for this opportunity again. I too use AI, right? We use it in the clinic. When a patient writes me a message through the portal, the first reply comes from generative AI. We're using ambient note taking in the clinic. We're using predictive analytics for sepsis and so on. So definitely out there. I would say in some respects, when I'm following fairness metrics, believe it or not, I see more attention to fairness metrics in some of the industry activities than I do in our own health system. So that example I gave you is something called the HEAL metric, H-E-A-L metric for fairness, developed actually by Google. So industry in some ways has been at the forefront of developing both fairness metrics and the tools that can be used to identify issues of fairness in data sets and in the performance of AI algorithms. So when I start to poke around and learn about them, that's actually where I'm going. When it comes to the health institutions, I can speak for our own as well as two published examples of AI governance structures. Those AI governance structures are from Stanford, has published on their governance structure, and so has Duke. Those are the two I'm most familiar with, of course, as with our own. And our own approach to fairness does involve an AI governance committee that engages in regular evaluation of model performance along those lines of protected characteristics. Now, what counts as regular? What counts as performance? What counts as fair? All really open questions. But we do have a process for pausing and evaluating performance of algorithms over time. Again, partly motivated by that state law I referenced. UC Health, we know that we will be held to that standard of steps taken to identify and manage bias. And so we're developing governance structures to do so. Now, again, that next level question And then I'll stop. Sorry for the long-winded answer. The next level question is, well, what is the best governance structure? And I think the answer is we don't know. Stanford, Duke, and ours all differ in very important ways, and I don't think we know the best way to do it, but there are activities. So I hope that helps start to answer your question.
Matt, I have a couple questions. I'm very worried about AI for a couple of reasons, and I'd like your thoughts on them. One is you identified the fact that the data out there is, at least in health, is pretty much now included in most of the data sets that AI is. So let's talk about the medical record, for example. So what's going to happen to physician notes is increasingly they're going to be written by AI in some form, because you know, as a physician, that the current medical record is pretty much impossible, where people are going to work and they're going to use every shortcut they can. So using the electronic health record in an AI sense means you're going to be examining your own belly button, because you're not going to be getting new information. You're going to get algorithm generated information, which is going to become the truth. So comment on that. And then question number 2 is, you talked about authentic community engagement. So I went to ChatGPT while you were talking, sorry. And I said, what is engagement? And it gave me a word salad. Building genuine, meaningful, and respectful relationships between individuals, organizations, or institutions. I don't know how you measure those things. So.
Yeah, two great questions, and I love your analogy to staring at the belly button, right? And I think that is the fear. There's a popular book called The Loop, which sort of describes the illusion of increasing choice through AI, and instead says that no, actually what happens is that the choice architecture narrows over time. The more we use and become reliant on a particular technology, the less new stuff we have. And I had the good fortune to talk to a national library conference about this issue, and we had a robust debate actually about whether what's created by AI is ever really new. And it's an interesting thought, right? Like, is that picture I showed you, while shocking, is it new? And what happens if we get into a negative feedback loop, a reinforcing loop, where all the information becomes the same? And this is where I think misinformation really comes into play. And your example of the health record is, as you said, a really important one, and one that's active right now. Of course, issues of hallucination, so to speak, also come up in those ambient technologies. We've seen that as well. So I just think a real problem. I can't also help but think that it connects to issues of de-skilling in research and training, that the more we become reliant on the technology, do we lose foundational skills? You recognize the problems in that output around community engagement because you're familiar with this space. What happens when people who are not trained in the same way now use that technology or over rely on it? I think it's a really important question. The idea of authentic community engagement, I will say, it's a good time to be an AI ethicist. It's a good time to be in community engagement, because many of the requests for proposals absolutely require community engagement, absolutely require AI ethics be a part of it. And I love that. And I like to emphasize that there is an entire science to community engagement. There are better ways of doing this. PCORI, has a science of engagement entire initiative that looks at developing the evidence base for what counts as effective, authentic community engagement with real tracking of outcomes. And so for questions of community engagement, I do like to point toward that space and say, actually, you know what? There are rigorous ways to do this. There are rigorous ways to do it that matter, and we need to do more of it. I don't know if that answers your second question about community engagement. I may not have understood it completely.
Well, I think that defining what that is as subject to the biases of all the other, examples that you gave. That's my, what do we mean by this ultimately? Who determines what's authentic? And I have this specter of Big Brother kind of seeping into this that makes me a little nervous as well.
I'm nervous too. I was just poking around, believe it or not, and I guess I shouldn't be surprised by this, right? But I was poking around about AI and community engagement and came across an article that basically says, well, we don't need community engagement anymore, but we can just have AI do it. And then I was like, oh my gosh, now I'm all tied up in knots because now I'm not only talking about AI and community engagement as a solution, but now AI is going to replace community engagement. We don't have to go engage communities anymore because we can just use AI to find out what we need. It's available 24/7. It's more efficient and so on. And so really easy to get tied up in knots.
Yeah, or Matt, sorry to interrupt, or we don't have to look at x-rays anymore, to your first point about skill degradation.
Well, yeah, thanks for that too. Another conversation I think worth having is in the language we use. And I hear people suggest that just remember, AI is just a tool. And I say, not so fast, right? The tools we use have the potential to change what we do and how we think. And will AI be a tool like we think of a calculator? Or will it veer into automation complacency like we've seen in the airline industry, where critics have said there's over-reliance on technology, to your X-ray example, and we lose the foundational skills and we lose that? What happens when we lose the technology? Over-reliance on autopilot having been blamed for certain disasters in the airline industry. Which is it going to be? And then people push back and say, well, no, it is just a tool. So go to your example of ambient clinical note-taking. I like to point out that, in fact, that will require changes in what I do as a clinician. Now, for that ambient note-taking to capture the physical exam, I have to articulate it as I do it. I wouldn't ordinarily do that. Now, some clinicians might, and in pediatrics, they might do it more than adult medicine. But it certainly starts to change what I do in that interaction with the patient, when now I have to say, your heart has a regular rate and rhythm with no murmurs, rubs, or gallops, and your lungs are clear. And oh, what's this funny mole I saw on your shoulder? Changes what we do. So a little bit more than a tool. It's too simplistic, I think, to call these mere tools.
Thank you. Oh, come on.
Other questions? Comments?
Hi, Matt. I have a question. Wonderful presentation. I do wonder if you have sort of like immediate practical implementation advice for working AI in this space, like especially in like the supervised setting. Right, we can think of like, I don't know, evaluating AI performance across like various race, ethnicity, age cohorts, or things like that. But are there sort of like, I don't know, practical limitations of like, hey, we a priori specify like, hey, we're a do no harm fairness metric type of thing we're trying to optimize, and from there we want to make sure that metric stays positive or something like that. What's sort of like the current, I guess, standard here?
Yeah, thanks for the question. It's a great question. I don't know that there is a standard. We're kind of making this up as we go. And I can only speak to this loosely from personal experience in our health system. And that is that we have taken the approach of, maybe you would call it, a multidimensional evaluation of performance and fairness. So we actually want to see, to your question, no one is worse off. We'll start there. Okay. Now we look at performance along characteristics, but characteristics also that we would hypothesize in advance may be likely to be related to, inequalities in performance. Then we might take the next step and look at, well, how does positive predictive value and negative predictive value differ? And then we put those different metrics always, and I think this is pretty important too, it's always within the context of the decision of the use case in question, right? Because it's very different to me if we're predicting sepsis deterioration in the hospital, which could be a high mortality event, right? And discharge planning needs. I see those as being different in terms of their level of risk, and what we expect or demand of those fairness metrics, I think, can appropriately be different based on that context. So I think the context of the AI you might be considering or the implementation in question is going to really drive a lot of the decisions we make about which fairness metrics take precedence in any one particular situation. So that's sort of what we're doing.
Thank you.
I have
Yep.
another time for another question. So, Matt, when you read the early works about the electronic health record back from the late 1960s, like Lawrence Weed, I'm sure you're familiar with the Weed system, we all are. And, you know, he was a pioneer in understanding what digitization and digital information could do. And what the electronic health record, it didn't accomplish what he had hoped for, which was to improve the doctor-patient relationship. It kind of did the opposite. And, you know, people are talking about this, and what I think I've observed in my career is that as you had more automation, you did more things. You were expected to do more things. The tasks increased. So isn't there a worry, and you know, the fairness issue, of course, is critical, but all of the additional tasks that you will presumably be able to do because of AI are going to be, somebody's going to have to do them. And the question is, are we going to end up with sort of in the same situation where, because we have AI, the physician is going home and spending another 2 hours filling out the new electronic health record, which now will include areas that we had never been able to, fairness, social determinants, et cetera, et cetera.
I think it's another great question, and it is a worry. This came up, this exact question came up related to our own implementation of Abridge, the ambient note-taking technology that we're using, where clinicians in our meeting were saying, are you just going to expect us now to see more patients because we're not writing the notes like we used to? And you know, the pessimist, of course, sees the history of the EHR like you described it as a cautionary one, that in some ways, you know, reference other classic literature. You know, we're waiting for Godot. We're waiting for this magic technology that lets us get back to that human connection. I think it's an open question. I will say that I'm not a user of the ambient note-taking technology. I wasn't chosen for the pilot. The people who have been using it in our clinics absolutely love it and feel like it's allowing for that connection. The data from Intermountain and Kaiser are not necessarily as positive in that way, as far as reducing pajama time or reducing things we might care about, like burnout and so on. But those studies are early, and the technology is early too, and is likely to get better. The concern you express, I'd also say, by the way, has also been flagged in research operations, right? That automation coming to research now replaces people in the research workflow. And what are the implications of that for how we think about ethics and the conduct of translational science now that that workflow looks much different as well, replacing humans? I think it's an open question. It's also, as much as I worry about technology at times, I also like to talk about the reassurance of history, where the medical profession over time opposed initially, or was very skeptical of, the stethoscope, opposed, very skeptical of the telephone, because doctors would be on call all the time if you had a telephone. And yet we do adapt to those technologies, and I hope that that's the case here, that we adapt to the technology and are able to use it. But, you know, the market forces that are around us and the forces that control EHRs and those sorts of decisions are not always under our control. I'll make one other comment. As much as we talk about bias and discrimination and all the concerns, the other worry in my head that I think about is, are we engaging in AI exceptionalism? Are we demanding too much of AI? With analogies to HIV exceptionalism and genetic exceptionalism in the past? Are we holding AI to some sort of unfairly higher standard or threshold for the way we approach it simply because it's new and scary? You know, the example I give there is in the ethics concept of explainability of AI. People want AI to be interpretable and explainable. And well, we're not going to use it if it's not explainable. And I say, well, in clinical medicine, I think I probably can't explain half of what I do. So why should AI meet that standard of explainability and interpretability when general practice may not meet it either?
All right. Well, thank you so much. That was really a very exciting presentation. I heard your short version at the NCATS meeting, but yeah, this is absolutely always wonderful.
Great. Thanks again. Thanks again for the opportunity. Yeah.
Thank you, Matt.
Thank you.